Hello, my name is John Willie, and this is the follow-up to my traffic optimization using motion control. I'm still in EEC414, and this is still the spring semester of 2019. Our agenda today will be very similar to the agenda of the first PowerPoint. It will begin with the abstract. After this, it will lead into the introduction and background. From there, we'll go on to the project objectives. And after this, we'll have the methodology. The methodology includes the components, hardware and architecture, software architecture, and the budget. There's also some small added parts to this that will discuss how the project went and any problems that we ran into. After this, we will go over the timeline, followed by the conclusion. Finally, we'll go over the references that were used for this project. So the abstract, being stuck at stoplights is a problem that plagues daily life for everyone. This project will remove the situation of sitting at an empty intersection. If there are no cars driving through a green light for 8 seconds, the light will turn red. For the project, 8 seconds was the test time for this, but we ended up finding that 12 seconds was the optimal time to wait in between cars. This was found by sitting at the test intersection, and we had a couple of the team members over there, and they tested it just to figure out which would be the best. The test run was run in a small city, which was the final stage of the project. And then finally, the whole project was a proof of concept, and we used that to sell the system to other cities. We currently have 2 cities that have contacted us that are nearby that want to purchase the system and use it in theirs. So it's already a success. Once again, being stuck at a stoplight is a problem that plagues many. This causes for increased pollution from cars, because anytime a car operates below 15 miles an hour, the emissions are increased. Being stuck at a stoplight increases the frustration of a driver, which increases the probability of an accident. It was found in this study that a driver becoming more and more frustrated increases the likelihood that they will become a part of an accident. And being stuck at a stoplight for minutes on end is a problem that can exasperate this frustration of the driver. Other methods of our system require tearing up concrete to put in the sensors, and this is a costly method to go about the traffic light system. And it will also require the intersection to be out of operation for weeks to months at a time due to concrete needing to be torn up and then replaced. The city that this took place in was not very large. There was 43 intersections in the city. The objectives that we had were to develop the motion sensing hardware and to build a prototype. We also wanted to develop the software for this project and to make it work in conjunction with the current traffic algorithm in place. We also wanted to implement a test run of this system in the city and monitor it, which we did. And finally, we wanted to prove the concept for future implementation in other cities, which we successfully did. Our components were 1 Arduino microcontroller, 4 motion sensors, various wires. The total cost per unit was about $55, and the final product did need an external shell after it fell out of the test intersection and one of the motion sensors fell off. The motion sensor still worked, but we figured that we would need to put shells on all of the individual units just so that they won't fall apart or fall off again. These shells cost about $5 each, so the total cost per unit ended up being $60 per unit. This was the hardware architecture. This is how we ended up building the whole system. The only difference is we added the shell to the outside of it, but this is it. So this is the software architecture for the algorithm that we have created for the project. This system did not replace the whole traffic algorithm, but it simply supplemented it. The algorithm did stay true to this. There wasn't any other part, or there were a few other parts that need to be added in the final implementation of it, but this is the basic gist of it. We did find that 8 seconds was too short to wait in between automobiles, so we upped that to 12, which was found at the test intersection. And this allowed for enough time to be in between cars that it wasn't just changing every time there was a gap in between two cars. And that we found that to be the perfect time. The experimental test bed for this is just where we did most of our testing for the small products, or the small project in our office. We used a corridor in our office that was 30 feet long, which allowed for the motion sensor range to be tested. We tested each of the motion sensors that we received so that all the units would be properly ranged. All were within acceptable range of effectiveness, and many of them worked for an extra 5 or 10 feet, which allowed our range to be a bit larger. This allowed for us to have, if there was any larger intersections, the better motion sensors were placed in those, and if there were some motion sensors that weren't quite as good, they were placed in the smaller intersections. The results, as I stated before, our project ran into a slight problem with how frail it originally was. When it fell out of the intersection, or the motion sensor unit fell off of the rest of the unit and into the intersection, it still worked, but we didn't want this problem to continue in the future. So that's when we invested money into the shell unit for the rest of them. This fixed all the problems, and after this, none of the motion sensors fell off any of the units, and all the units are still in place at the moment, working fine. The intersections in the city are now 17% more efficient, which allows for reduced traffic, emissions, increased morale of the general public. It's allowed the city's traveling system to be much more efficient and beneficial. And then now 2 neighboring cities have also contacted us to purchase this system, and we'll be working with them now after this project in order to fulfill their request. This is the original budget that we had. We ended up using slightly more money due to needing to rent the lift truck again to fix the motion sensor that fell off, and also to purchase the shells for all the units. But this ended up being an extra $3,000-ish just in general to add on. So even though this was a bit more than we were expecting, it's still well within a percentage of what we wanted. This was our original timeline, which was broken up into the 5 different parts, or the 4 different parts. We managed to follow this Gantt chart perfectly because we allowed some extra time in there to work on the certain things that went wrong. The building and troubleshooting phase lasted a little bit longer than this, but that was fine because some of our operators, like, it was just the hardware getting it down perfectly so that each unit was durable. During this phase, we monitored the test intersection for the optimal time and found that it was 12 seconds. We built and tested the software and hardware, although the hardware wasn't up to our standards. And the troubleshooting phase allowed for a slight time buffer, but it was a day or two too short. The first installation took place on the 29th of July. We installed the system at the first intersection, and we did rent the lift truck for this. We then uploaded the survey for the citizens to leave comments, and we found that the system was not used as often as we had hoped it was, just because people often will not do a survey if they don't have to. We did get some helpful comments on it from people saying, like, at certain times when it wasn't working and we were able to fix the software in the system through this for all the future ones, but oftentimes it was just not used. From the 30th of July until the 26th of August, we monitored the system and built the other units for the intersections. At this, we did have to take down the system when one of the motion sensors fell off and put the shell on. After that, we continued to monitor the system, and we found that there were not many problems, and we did build the 42 other systems. Citywide implementation lasted from the 26th of August until the 30th of September. We installed the 42 other systems at all of the intersections, and the entire city was using this system. This entire phase went just as planned because we were able to build the units in the last section. We were able to get 1 to 2 units up a day, and it went smoothly. The future, looking into the future now, we'll have to expand our team to allow for selling the system to cities in the future, and also for the installation in the 2 neighboring cities, as our team is too small for these larger cities, and we are only able to work on 1 city at a time. So we will have to upgrade or increase our team. We also need to look for some cheaper sources for the materials, just for the motion sensors, as they're a bit more expensive than we had hoped we would find originally, but they were the best that we could. So we can start contacting other suppliers of electronic goods to find these materials. We could purchase lift trucks, or we will purchase lift trucks to eliminate the need for renting them, as these costs were not significant upfront, but if we are going to continue doing this for other cities, it is necessary that we have our own lift trucks just to maintain a professional image. And we also have to market this to other cities after we complete the installation in the 2 cities. Some lessons that we learned was to allow for a slight surplus in budget for any problems that might arise, as our budget was quite good for most of it, for everything that we had planned for, but we were not ready to need to rent the lift truck an extra time and also purchase the shells for the durability. We also need to learn to expect that Mother Nature is rough on parts and materials, and we need to strengthen our units before we install them, just so we can prevent this in the future. In conclusion, this project helped to remove a major headache that affects commuters. It helped to reduce emissions from automobiles in the city and helped to clean up the environment. It also increased the efficiency of the roads in the city by 17%, allowing for people to travel through the city much quicker and trouble-free. And we now have 2 cities that are interested in purchasing this system, achieving our final objective and allowing for us to profit off of this idea. Here are the references that I used for this, and thank you for listening.